So hi everyone, today I'm going to discuss another type of conic section, which is an ellipse. So how is ellipse being formed? So an ellipse is being formed if the plane intersects one nape at an angle to the axis other than 90 degrees, then the conic section is an ellipse. So what is an ellipse? An ellipse, this is the set of all points in a plane whose distance from two fixed points called foci is constant. So the standard equation of an ellipse is represented on these two equations. So they're actually the same. The only difference is that the value of their denominator. So if you have, for example, quantity x minus h squared all over a squared plus y minus k squared all over b squared equals 1, where a is greater than b, then the major axis is horizontal or it is parallel to the y-axis, because if you have noticed, our bigger denominator falls under x. Okay? Now, the second one is that quantity x minus h squared all over b squared plus quantity y minus k squared all over a squared equals 1, wherein a is bigger than b or greater than b, which means our bigger denominator falls under y. In this case, the major axis is vertical, or this is parallel to the y-axis. So, on this table, you will see the center, the vertices, the foci, the endpoints of the minor axis, and the major axis. So in the equation wherein our bigger value or bigger denominator falls on x, the center still is at hk. However, our vertices is located at h plus minus ak. And our foci is located at h plus minus c and k. Endpoints of the minor axis is at h, k plus minus b, and the major axis is horizontal. Now, if your bigger denominator falls under y, or you have the second equation, then still the center is at hk. However, your vertices lies on h, k plus minus a, and your foci lies at h, k plus minus c, and the endpoints of your minor axis lies at h plus minus b, k, and the major axis is vertical. Okay, so to understand more the ellipse, we have example number 1. So graph the ellipse described with the equation quantity x plus 1 squared all over 9 plus quantity y minus 2 squared all over 25 equals 1, and identify the center, the vertices, foci, and endpoints of minor axis. Now, you will have to consider first the equation. Which value or which is has a bigger denominator? If you try to look at it, under the quantity y minus 2 squared has the bigger denominator, which is 25, which means you will have the idea that our ellipse has the major axis of the ellipse is vertical, right? Or it is parallel to the y-axis, because the bigger denominator falls under y. So now we're going first to identify or find our c. So we are given that our a is equals to 5 and our b is equals to 3. Where did we get this one? So remember, the bigger value is always a. Bigger denominator, rather. Alright? So how we get 5? So if you try to go back with our standard equation, it is presented as a squared and b squared, which means to solve for a, all we have to do is to find the square root. Okay, the square root of a. So a squared. So the square root of 25 is 5, and the square root of 9 is 3. With that, we're going to solve now for c using the equation c squared equals a squared minus b squared. Now in this case, you're going to we will now have c equals the square root of a squared minus b squared. So the 5 squared is 25, 3 squared is 9. So 25 minus 9 is just 16. And the square root of 16 is 4. So now you already have your A, your B, and your C. So now let us identify the center. The center is at HK. So always remember this is an opposite sign. So our HK is located at negative 1, 2. So since this is positive, it becomes negative. This is negative, it becomes positive. So negative 1, 2. Our vertices, according to the previous table, since our major axis is at vertical, so that means we will be changing with our y coordinate. All right. So then the vertices is presented or can be solved using hk plus minus a. So our h is negative 1, our k is 2, our a is 5. So negative 1, 2 plus 5, that is negative 1, 7. And 2 minus 5, it's negative 3. So our vertices is located at negative 1, 7 and negative 1, negative 3. And the foci, so still have to remember, so if the bigger denominator falls on like the y values, the vertices and the foci, all we have to change is still on the y coordinate. So we won't be changing the x coordinate. So at the foci, you have hk plus minus c. So our h is still negative 1, our k is 2, and our c is 4. So 2 plus 4 is 6, and 2 minus 4 is negative 2, which means our foci lies at negative 1, 6, and negative 1, negative 2. Now at this point, it is now easy for us to graph our ellipse, right? And then we're going to have the last one, which is the endpoints of the minor axis. So the endpoints of the minor axis, so you will have h plus minus bk. So our h is a negative 1, our b is a 3. So negative 1 plus 3 is 2. So, and negative 1 minus 3 is negative 4. So the endpoints of our minor axis lies at 2, 2, and negative 4, 2. And now this is our graph. So if you try to look at it, no, our graph, the ellipse is vertical to the parallel to the y-axis. No? Okay. So second example. Okay, so now we're going to move to our second example. So our second example is to reduce the standard form the equation of the ellipse 4x squared plus 9y squared minus 40x minus 54y plus 145 equals 0. So we're going to graph the ellipse and identify the center, the vertices, foci, and the endpoints of the minor axis. Now to do this, we will be using your past knowledge of the completing the square. So we'll have to complete the square of y, and then we have to complete the square of x. So with this, if you have noticed, we already transfer the constant on the other side. So that gives you the idea of 4x squared minus 40x plus 9y squared minus 54y equals negative 145y. So second step is we're going to factor out, no, because remember when you complete the square, the coefficient of your x should be 1, right? So that means we'll have to, for our x, we're going to factor it by 4, and for our y, we're going to factor it by 9. And it will now then become 4 times quantity x squared minus 10x, because it's negative 40 divided by 4, that's negative 10, plus 9 times quantity y squared minus 6y, because negative 54 divided by 9 is negative 6, equals negative 145. Now remember, to complete the square, all we have to do is to look for the linear term. So, and then we divide it by 2 and we square it. That means negative 10 divided by 2 is negative 5. Negative 5 squared is 25. And negative 6 divided by 3, by 2 is negative 3. And negative 3 squared is 9. Which will then become, you will now have 4 times quantity x squared minus 10x plus 25 plus 9 times y squared minus 6y plus 9 equals, okay, now this is mostly where students fail to understand, or solve for the correct answer. You have to remember, whatever you add on the right side will always be the same thing that you're going to add on the left side. Now, since we factor the x by 4 and we factor the y by 9, then when we going to add 25 and 9 on the other side, it should be multiples of 4 and multiples of 9 respectively, which means on your left side it will then become negative 145 plus 4 times 25 plus 9 times 9. Now you will now have 4 times quantity x minus 5 squared plus 9 minus y 3 squared equals 36. Afterwards, divide in both sides by 36 to make it a standard form because it is always equivalent to 1. So we have 4 times quantity x minus 5 squared all over 36 plus 9 times quantity y minus 3 squared all over 36 equals 36 over 36. So 4 and 36, it becomes 9, right? And then 9 and 36, it becomes 4. So now you will have quantity x minus 5 squared all over 9 plus quantity y minus 3 squared all over 4 equals 1. Now in this case, you will have 2. Okay, can now determine your A, your B, and your C. So on this scenario, your A is equals to the square root of 9, which is 3, and your B is equals to the square root of 4, which is 2. So still, we're going to solve for C. And okay, so we have here 3 squared minus 2 squared, that's 9 minus 4, that's equivalent to square root of 5. So our C is square root of 5. So that means our center here, still at HK, is at 5, 3. Our vertices is at, okay, so try to think about it. Now observe our standard equation. Our standard equation, our bigger denominator falls under x, right? Which means our major axis is horizontal, or it is parallel to the y-axis because 9 is bigger than 4. Which means for your vertices and your foci, we will be changing our x values. Okay, so we have 5 plus minus 3, 3. So 5 here is our h, and our 3 here is our a. So 5 plus 3 is 8. So, and 5 minus 3 is 2. So our vertices is located at 8, 3 and 2, 3. And for our foci, so we have h plus minus ck. So we have 5 plus minus square root of 5, 3. So remember, we cannot simplify or add a whole number to a radical. So we'll just have to copy it and we'll just have to change the sign. So you will have 5 plus square root of 5, 3 and 5 minus square root of 5, 3. And for the endpoints of our minor axis, so you will have hk plus minus p. So we have 5, 3 plus minus 2. So 3 plus 2 is 5. 3 minus 2 is 1. So our endpoints of minor axis lies at 5, 5 and 5, 1. In this case, so this is our graph. Okay? Again, our graph is parallel to the x-axis. Okay, so palapad siya painan. Alright. So third example. So in our third example, determine the equation of the ellipse with center at 0, 0. Major axis. Alright? The major axis is on the y-axis. And the length of major axis is 6. And the length of minor axis is 2. So an ellipse with major axis on the y-axis is the standard form quantity x minus h squared all over b squared plus quantity y minus q squared all over a squared equals 1. So why this is the standard form? Because our major axis lies on the y-axis, which means it is bigger. Alright? Okay. So in this case, our center is at still 0, 0 with h equals 0 and k equals 0. And our major axis is equals to 2a. So major axis is 2a. So according to the problem, the length of the major axis is 6. So to solve for A, 2A equals 6 or A is equals to 3. And the minor axis is 2, so 2B equals 2 or B is equals to 1. So you solve for C then. Going to solve for C. Alright. I know. So we won't be solving for the C because all we have to do is to determine the equation of the ellipse. So the equation of the ellipse then is, okay, we're going to use this idea. Alright, so we have our A, R, and B already. So our equation then is at x minus 0 squared all over 1 squared plus y minus 0 squared all over 3 squared equals 1. So simplifying, you will now then have x squared over 1 plus y squared over 9 equals 1. So this is the equation of example number 3. Alright? And this is our graph. Okay? You have noticed here? Alright. Sige. So next, example number 4. So in example number 4, determine the standard form of the equation of the ellipse having foci at 0, 1 and 4, 1 and a major axis of length 6, and then graph the ellipse. So our center is between the two foci, right? So therefore, we're going to use the midpoint formula. So 0 plus 4 over 2 and 1 plus 1 over 2. So 0 plus 4 is 4 over 2 is 2 and 1 plus 1 is 2 over 2 is 1. So therefore, our center is at, okay, 2, 1. Our C here is equivalent to 2 because remember that the C is the distance between the center to the foci. Okay, center to the foci. So which means our C is just 2. How to get that one? So you can actually use the distance formula, or you can just plot the foci and the center, and you just count the grades, and you will see that your C is equivalent to 2. And our major axis is equals to 2A, which is equivalent to 6. So our A here is equals to 3. In this case, our B is at square root of A squared minus C squared equals, okay, square root of 5. Now to continue, example number 4, the major axis is horizontal. So horizontal siya, and the standard equation is given by this equation. So that means you will have x minus 2 squared all over 3 squared plus y minus 1 squared all over square root of 5 squared equals to 1, and voila, this is your equation. Quantity x minus 2 squared all over 9 plus quantity y minus 1 squared all over 5 equals to 1. Alright? And this is our graph. Next, last example, example number 5. So find the center, vertices, and foci of the ellipse 5x squared plus 9y squared plus 10x minus 54y plus 41 equals 0. So we have here, again, from the previous example, first is we will have to use the completing the square. So we have moved the constant to the other side. So that's why it becomes negative 41. Because it is originally positive, right? So when you transfer, it becomes negative. So factoring 5x squared and 10x by 5. So you have quantity 5 times quantity x squared plus 2x, and then plus 9 times quantity y squared minus 6y equals negative 41. Now, complete the square. So it's 2 divided by 2 for the x. So you have 2 divided by 2, and then is 1, and then 1 squared is just 1. And negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. So we have quantity 5 times quantity x squared plus 2x plus 1 plus 9 times quantity y squared minus 6y plus 9 equals, again, whatever you add on the right side will always be the same thing that you add on your left side. So you will have negative 41 plus 5 times 1 plus 9 times 9. Alright? And alright, there you go. So you have 5 times quantity x plus 1 squared plus 9 times y minus 3 squared equals 45. Divide on both sides by 45, and you will then now have quantity x plus 1 squared over 9 plus quantity y minus 3 squared over 5 equals to 1. With this, we can now identify our A, our B, and we're going to solve for our C. So again, our A is the bigger value. So the square root of 9 is 3, and the square root of 5 is just square root of 5. So we're going now to use this one to solve for C. So we will have 3 squared minus square root of 5 squared, which is 5. So 9 minus 5 is just square root of 4, and the square root of 4 is just 2. In this case, our center is at -1, 3. Alright? Our vertices, so if you have noticed, no, our bigger denominator falls under x. So therefore, for the vertices in our foci, we will be changing on our y coordinate. So h plus minus ak. So -1 plus minus 3. So we have -1 plus 3 is positive 2. -1 minus 3 is -4. So our vertices lies at 2, 3 and -4, 3. And our foci, so we have h plus minus ck. So -1 plus minus 2, 3. So -1 plus 2 is positive 1 and 3. -1 minus 2 is -3. So -3, 3. And the endpoints of minor axis, so you have h, k plus minus b. So we have -1, 3 plus minus square root of 5. So again, we can just simply add a whole number to a radical number. So we just have to copy it, and you just have to differentiate it with the sign. So you will have -1, 3 plus square root of 5, and -1, 3 minus square root of 5. So to graph, this is your graph. Alright? So I hope you learned something from me out of the examples given for the conic section ellipse. If you have questions, feel free to drop your questions on the comment section below. God bless everyone, and see you on the next tutorial.